So generally, intuitively speaking, is that what they actually try to find is that the biggest area. Uh, I mean, at first glance, is that um, that you want find biggest area for the water to actually store, and the pattern is definitely find two pillars that is like the tallest, which for this case is this one, and then this one that actually form the biggest pillar for one to actually hold the water, right? So um, intuitively speaking, straight away we do have like some items that is under our arsenal for us to actually solve the problem. So it's definitely using the two pointer technique to actually solve the issue. So from previous, we actually did talk a lot about two pointer on how it actually solve. So for this very case is that uh, what they actually doing if one of the feature that they actually have for two pointer is about conditional statement. So with one conditional statement, then you kind of like shift um the so I mean there's two types, right? So you say there's a conditional that actually met, and you move one of the pointer, or the two pointer that actually move all together at once. And for this case is the more advanced one, which is we are using just one conditional met during stage 1, and then on stage 2 we move the one pointer for it, right? So for this very case is that we want the taller building, the taller barrier, and that's the conditional statement that I believe we are gonna use. So so what we actually do actually compare with is that there's both the L and the R, right? So which one is like bigger? If so, that's our conditional statement. So L is bigger, so we move the R. Which one is bigger now? Um, L is still bigger, so we move the R. Which one is, we think have a bigger area? I think L, so we move the L. Which one is taller? I think the R is still taller, R is still taller, and R is still taller, right? So that's how the intuition actually do work, and it's very much similar to our previous, just that the conditional this time around is slightly different. We are comparing both the L and R, which one is taller. If one is like shorter, we cannot like move. And obviously we did miss out on the L on the left edge cases. So I mean you can kind of like see for yourself is that L and R, which one is bigger? R is bigger, so we move the L over here. Then now L and R is like the one of like the biggest in my opinion, and sure enough we do get the biggest area by having these two L and R. And that we just continue like what we talked about like from previous, intuitively speaking. And um, and of course without a doubt is that and of course if you can do two pointer for this two because fundamentally speaking what we are talking about is that we're having a plus b equals to some sort of like a imaginary target value, which is for this very case is we're talking about the max area. Although it's like not a very much of a for a very typical case is definitely we are having a stage z of having a plus b to meet a certain target. But for this very case is slightly different, which is falling under the category of like stage y. So it's having the combination of like a and b, and under the influence of the a and b, you get a random element, and for this random element, for this very case, is talking about the max area. And based on where you place the a and b, your max area will kind of be different based on different situation. So for this very case is that if your a and b is under the very tall places, it will generate you a very big area. But if your a happens to be at a very short area, and the other one also very short area, you therefore get a one time, like you get a very short area, which is not very ideal, because at the end of the day, what you really want your random element to be as high as possible. And for as high as possible, there's actually two conditions to actually meet. So the first condition is actually talking about I want the tall barriers to be existing for the a and b conditions. So for my a and b, I want it to be on the very high node of things, which is for this case, it will be here, it will be here, and it will be here, right? And the second condition that to actually make this as high as possible is that you want to spread your area to be as far as possible. So it's talking about your a and b, the separation must be as far as possible. So you start off with your a and b to be on the far edge on the left and far edge on the right, which is one of like the basic fundamentals of like two pointers. Two pointers, you usually start off by having counting the edges from all the way to the edges, all the way from the left and all the way from the right. So it does actually complement into finding this random element to be as high as possible. So if we did not actually talk about, I actually don't actually know that we can actually come to this stage about talking about this unique feature that is catered to this container with most water problem. I think this one is like a unique feature that this problem statement does hold. Because as opposed to this stage y, we traditionally do a problem with stage z, whereby we usually a plus b equals to a target value. So far past two sum problem, it was like through state z, which is a plus b equals the target. This time round, we're looking at like on a different angle, but I think it does actually use the two pointer to it in a different angle, but it's still using the two pointer to actually complement to fit into the criteria of like our problem statement. So having said that, I mean, if you were to go to the state Z, the traditional problem, which is the a plus b, and then getting the target, uh, you use a two pointer, and at the same time, on the flip side, you also can use the brute force. So very similarly for this case, for stage Y, you also can use the brute force method to actually try to find your answer, and that will be definitely a person intuitively speaking, they will actually try to do that first. So what are we actually talking about? Which is something that they also actually discuss a lot about, which is that for here is that they start off by putting the L and the R over here, and then they slowly spread, and then they slowly like count the area, right? So eventually it does reach until here, and then the area is still very small, and then when they suddenly start off with here, and then they suddenly see that, oh damn, this area is pretty big, it's like 49, and I think we actually do find our solution here. So brute force, definitely you do find the answer, but everything always comes down back to the time complexity issue, which is that for brute force, for this case, because it's two variables, it will be sort of like a n square complexity, and for two pointer, it's just n times. It's just n, right? For the time complexity. So yeah, there you have it. Everything comes to an end.